Hello everyone. In this presentation, I will solve this mathematical problem which is based on Kirchhoff's law. I have given you the idea about Kirchhoff's law in my previous lecture. I hope everybody now understand what is Kirchhoff's current law and Kirchhoff's voltage law. In this circuit, you see there are two closed loop. We have 2 ohm resistor, 8 ohm resistor, 4 ohm resistor. This is 10 volt source, this is 6 volt source, and the voltage drop across 2 ohm is V1, voltage drop across 8 ohm is V2, and voltage drop across 4 ohm is V3. The current is I1, I3 and I2 in this node, and you have to calculate I1, I2, I3 and V1, V2 and V3, basically all the node voltages and all the node branch currents. Now let us solve this problem. See, since this problem is based on both Kirchhoff's current law and Kirchhoff's voltage law, because you have to calculate both current and voltages here, so you have to apply KCL and KVL. Okay, so what do we need? We need both KCL and KVL. Okay, what is KCL? Kirchhoff's current law. And why do we use Kirchhoff's current law? Why do we apply Kirchhoff's current law? We apply Kirchhoff's current law at node. Okay, Kirchhoff's current law is applied across a node. Why do we apply Kirchhoff's voltage law? We apply Kirchhoff's voltage law inside a loop. Okay. Okay. Now, suppose this is a node B. In this circuit, this is a node B, because this 2 ohm resistor, 4 ohm resistor and 8 ohm resistor, these three branches are connected there. We know node is a point where multiple branches are connected. So at node B, okay, so at node B, I told you earlier, to apply KCL you have to have identify the number of nodes, or the point inside the circuit where you can apply KCL. Okay, to apply, I'm telling you again, to apply KCL you have to find where the currents have met. Okay, where the currents have met, or the node. Now at node B, see, at node B, I1 current is entering, so this is positive I1. I3 current is leaving, so this is negative I3. You know that the leaving current has opposite polarity, and I2 current is also leaving, so negative I2, and the total algebraic sum of this current is equal to 0, which gives us that I1 minus I3 minus I2 is equal to 0. In short, we can write that I1 minus I2 is equal to I3. This is our equation 1. Okay, we will need that equation later on. Now, here are two loops. Okay, so we have to travel inside this loop in either clockwise or anti-clockwise direction. Suppose we are traveling clockwise direction here. Now in loop 1, okay, this is our loop 1. In loop 1, suppose you are starting from point A. Okay, this is A, B, C, D and A. Okay, A, B, C, D and A. From A to B, we are having voltage source V1, voltage drop V1, and have positive polarity, so plus V1, this is plus V2, because you are entering the positive terminal here, and this is minus 10. The total algebraic sum is equal to 0, which will give us that V1 plus V2 is equal to 10. Okay, V1 plus V2 is equal to 10 here. Now what is V1, students? V1, see here, in 2 ohm resistor current is I1. Okay, in 2 ohm resistor the current is I1, so V1 is basically, and the current I1 is entering the positive terminal of the resistor, so basically V1 is 2I1. Okay, so V1 is 2I1, and what is V2? See, V2 is basically 8 times I2, and I2 is entering the positive terminal of the resistor. So V2 is 8 times I2. So from equation 2, what we can write, that 2I1 plus 8I2 is equal to 10. Okay, this is our equation 3. Now in loop 2, this is our loop 2. Okay, now we have to travel in clockwise or counterclockwise direction, but since you have chosen you have chosen to travel clockwise direction in loop 1, so you have to travel clockwise direction in loop 2. Okay, if we chose to travel counterclockwise direction in loop 1, then we have to travel counterclockwise direction in loop 2. Both the traveling path in loop has to be same. If the first one is clockwise direction, the second one has to have clockwise direction. If the first one you are traveling, if in the first one loop you are traveling in counterclockwise direction, then you will have to travel counterclockwise direction in the second loop also. Now in loop 2, suppose the loop is B, C, this is D, and this is point E. So B, D, E, C, B. Okay, B, D, E, C, B. We are traveling in clockwise direction. So we are traveling from B to D, D to E, E to C, and C to B. So from B to D, we are having voltage source V3, which is positive polarity. So positive V3, and we are entering the negative terminal of 6 volt. So this is minus 6 volt. Okay, from E to C, and from C to B we are entering the negative terminal of V2, so this is negative V2, and the total algebraic sum is equal to 0. So what we get there, we are getting V3 minus V2 is equal to 6. Okay, suppose this is equation 4. Now what is V3? What is V3, students? See, I3 resistor is entering the positive terminal of 4 ohm resistor, and the voltage drop across 4 ohm resistor is V3. So from Ohm's law we can write that V3 is basically 4I3, and we know V2 is equal to 8I2. So from equation 4, okay, so from equation 4 we can write that the value of V3 is 4I3 minus V2 is 8I2 is equal to 6. This is equation 5. So now we have three equations. First equation is I1 minus I2 is equal to I3. Second equation is 2I1 plus 8I2 is equal to 10. And the third equation is, so 4I3 minus 8I2 is equal to 6. We have three unknowns, I1, I2 and I3, and we have three equations. So if we solve these three equations, we are rearranging the equations here. So I am writing here that solving equation 1, 3 and 5, what we get? This is I1 minus I2. We are writing in the standard form. I1 minus I2 minus I3 is equal to 0. This is 2i1 plus 8i2. There is no i3, so we can write 0i3 is equal to 10, and in this equation this is 4. So sorry, there is no i1, so we can write 0 times i1. Okay, this is 0 times i1 minus 8 times i2 and plus 4 times i3 is equal to 6. So solving these three equations, what do we get? That is the calculator here. The three unknowns. So the first a1 is 1, b1 is minus 1, c1 is minus 1, d1 is 0, a2 is 2, b2 is 8, c2 is 0, d2 10, a1 a3 is 0, b3 is minus 8, c3 is 4, and d3 is 6. So what we are getting that I1, the value of I1 is equal to 3 amps. The value of I2 is 0.5 amps, and the value of I3 is 2.5 ampere. Okay. Now, what is V1? We know that V1 is 2I1. See here, V1 is 2I1. So the value of I1 is 3. So we are getting V1 is 2 times 3 is equal to 6 volt. What is the value of V2 then? V2 is 8I2. So 8 times 0.5. Okay, 8 times 0.5 means 8 times half, which is 4 volt. And is the value of V3. We know that the value of I3 is 2.5, and 2.5 times 4 is 10. So the value of V3 is 10 volt. So students, we have solved the problem, and we have find out every unknowns we have to calculate. See, this is I1, I2 and I3. Here are the value of I1, I2 and I3, and we had to calculate V1, V2 and V3. We have calculated V1, V2 and V3. So I hope you have understood the problem. This was a difficult problem, not that difficult also, but this problem will clear some concept of yours. So thank you. That's for today. I'll solve some problem in my next lecture.